All right, lesson 1.6, the other types of equations, day 2. So our objectives for this lesson are we're going to solve equations that are quadratic in form, solve equations involving absolute value, and solve problems modeled by equations. So an equation that is quadratic in form is one that can be expressed as a quadratic equation using an appropriate substitution. So when we're looking at a quadratic equation, and so let's just look at, let's say, x squared plus 2x plus 1, let's just say. Okay, so we know that this is quadratic. One, because we always say the largest exponent is x squared, right? And our exponents are in descending order. But it's also because this middle variable right here, if I take it and I square it, I will get the variable of the leading term. Okay? So it doesn't matter if I'm looking at something like if it was x to the fourth, I'm going to use the same coefficients here, plus 2x squared plus 1. Okay? This x squared right there, when I take x squared and I square it, that's x to the fourth. That's going to give me the variable of the leading term. I could take x plus 2 square root of x plus 1. Okay? If I take this exponent, if I take that middle variable right there, so the square root of x, and I square it, remember square root and square cancels. Oops, don't know where that came from, sorry. I get x, which is the leading term. Okay, or if I even had, let's say, some exponents here. I put a 2 back in there. Okay. So if I take that middle variable, the variable of the middle term, that x to the 1/5, and I square it, remember, you multiply your exponents. 2 is the same as 2 over 1, so you end up with x to the 2/5, which is that leading variable, okay? And it wouldn't matter if we had a number in front of that leading variable. It's a variable that matters, okay? So all 4 of these that I put up here are quadratic in form. The first one is the only true quadratic equation, but they're all quadratic in form. All right, so as we're going to work this problem and we're going to write some notes down at the same time here. So I'm going to kind of split my screen in half here. All right, so step 1 is you got to set the equation equal to 0. Well, for us, that's already done. Step 2. This is where we're going to do a substitution. So we're going to let the letter u equal the variable of the middle term. Okay, so whatever is after the coefficient of that middle term is considered the variable, okay? So for our sake, it's going to be that x squared because that's our middle term and that's the variable part of it. So for step 2, we're going to let u equal x squared. So for step 3, we're going to rewrite using u squared and u. Okay, so because we let u be that middle variable and we're going to set this up to be quadratic in form, we're going to rewrite now, instead of x to the 4th, we're going to put u squared minus 5. Instead of x squared, we're going to put u plus 6 equals 0. Now, if there had been a number in front of that x to the 4th, we would put that number in front of the x squared, okay? This will work every time like this. It's always going to be a u squared and then a u. All right, so now we do have a quadratic, right? So we're going to solve the quadratic. All right, so we have choices. We can factor, we can do the quadratic formula, or we can do completing the square. This one is factorable, so I'm going to go ahead and do that, but I know that some of y'all like completing the square better, so you're welcome to do that if you'd like. All right, so if I'm going to factor this, there's no greatest common factor. There's 3 terms, so it's a simple trinomial. So remember the 2 parentheses equal to 0. My first terms here have to multiply to give me that u squared at the beginning, so u and u. My last 2 terms here have to multiply to that 6 and then read it backwards. They also have to add to the 5. So 3 plus 2 is 5. Bigger number first, bring down the first sign. But remember, it's a negative 3 times what kind of 2? It's actually going to give me that positive 6 at the end, a negative. And then to solve them, we're going to set each of those parentheses individually equal to 0 and solve. All right, but we're not done yet because we really weren't solving for u, were we? What was in our problem? And our problem was an x. So step 5 is we're going to replace u with, and I'm just going to put step 2 because that tells us we're going to look back up here and make that substitution back, okay? So when I look back up at step 2 there, we had an x squared. So step 5 is it's not really u equals 3, it's x squared equals 3. And it's not really u equals 2, it's x squared equals 2. And then for step 6, we're going to solve for x. All right, so in order to solve for x, we're going to have to get rid of the square, so take the square root. So we get square and a square root cancel, so we get x equals. Remember, when you take the square root of a number, it's plus or minus, and we can't take the square root of 3 and we can't break it down, so leave it as the square root of 3. Okay, work the other one out. Got to get rid of the square, so take the square root. So square and square root cancel, so x equals. We're taking a square root of a number, so plus or minus. We cannot take the square root of 2, and we cannot break the 2 down, so leave it as the square root of 2. And so here are our 4 solutions, because we have positive square root of 3, negative square root of 3, positive square root of 2, and negative square root of 2. All right, so pretty much our steps are going to be the same for all of it until we get down to like step 5, or actually step 6, okay? When we go to solve it, you're not always going to take the square root. That was to get rid of the square. Okay, if it had a square root there, then we would square both sides. If it had a fraction, remember, raise it to the reciprocal. But this is how we solve using quadratic and form. All right, equations involving absolute value. Remember that absolute value of x describes the distance of x from 0 on a number line. So that means our absolute value, when we take the absolute value of something, it's never going to be negative. But what's inside can be positive or negative. So to solve an absolute value equation, we rewrite the absolute value equation without the absolute value bars. And so it says if c is a positive real number and u represents an algebraic expression, then the absolute value of u equals c is equivalent to u is equal to c, or u is equal to negative c. So what we're going to do here is the first thing is you got to get the absolute value by itself. Remember, absolute values, those 2 long bars, so I'm going to use that, okay? So if there's other numbers being added, subtracted, multiplied, or divided to that absolute value, you've got to get rid of them first, okay? Then we're going to split into 2 equations. One of them is going to have the positive of what's inside. The other one's going to have the negative of what's inside. So we would end up with like a positive whatever equals, let's say, c. And then we would have the negative of whatever was inside my absolute value equals c. And then we just solve both equations. All right, so let's try this. So here we have the absolute value of 2x minus 1 equals 5. One other thing, guys, first thing is make sure that the absolute value is by itself. And it is. If this had like a 5 up here, then we would have to divide by 5, okay? If it had a 6 plus, we would have to subtract the 6 to move it over. All right, but this one's already by itself, so step 1's already done. Now, once you get this absolute value part by itself, you need to check. That number cannot be negative, because when you take the absolute value, it's either 0 or a positive number, okay? So if that number, that 5, had been -5, this is no solution. I'm done. But it's not negative, so that means we have 2 solutions because it's a positive number. If it was 0, we'd end up with 1 solution, because when we work it out, they come out to be the same. All right, so because we got absolute value by itself, that number's not negative, we're going to split it into 2 equations. So we're going to take the positive of what's inside, equal to that 5, and we're going to take the negative of what's inside, equal to that 5. And then just distribute. So we get 2x minus 1 equals 5. Remember, it's like distributing a positive 1, or just when you distribute a positive, it doesn't change anything. So then solve this equation. So 2x equals 6, divide by the 2, and we get x equals 3. Then we got negative of the 2x minus 1, so we're going to distribute that negative, which is like a -1. Remember, when you distribute a negative, it changes the signs. So we got negative 2x plus 1 equals 5, and we're going to solve this equation. So we're going to subtract the 1, so negative 2x equals 4, divide by the negative 2, and we get x equals -2. And so there are our 2 solutions. The formula h equals -2.3 square root of I plus 67.6 models weekly television viewing time, h in hours, by annual income, I in thousands of dollars. What annual income corresponds to 33.1 hours per week watching TV? All right, so we noticed that they gave us an equation, so let's look at the equation. Identify what your variables represent. What is h? Well, it says h is the time in hours. What is I? It tells me I, there's the I there, so it's in thousands of dollars, but what's in thousands of dollars? The annual income. So h is our hours and I is our income. So it says what annual income corresponds to 33.1 hours. So there's our h. So 33.1 equals, and just copy down the rest of this. And then we're going to solve for I, so we need to get this piece by itself. So let's subtract that 67.6. I think that's negative 34.5. And then we're going to divide by that negative 2.3. And so negative 34.5 divided by negative 2.3 is 15. So we get 15 equals the square root of I. Remember, to get rid of a square root, we're going to square it. And so 15 squared is 225 equals the square and the square root cancel. So we just get our I. And so remember, I was the income, so the annual income is, and remember, income's in thousands of dollars. It's not $225, it's $225,000. And so I'm just going to write it as a number, $225,000.